Hello dear students, hope that all of you are doing well, and today is the continuation of the previous class. This is the second class on SageMath, that is lecture 1, because in the previous class we talked about some development of SageMath, why SageMath and some modern applications of SageMath, and also installation, how to install the SageMath. So hope that all of you have installed in your system. Maybe it is Windows, maybe it is Linux. So I gave you the guide for installation. So if you install the SageMath, let me show you on the screen. 3 shells will be created. So SageMath shell, SageMath notebook, and SageMath. So you just click on the notebook. The kernel will be open. This is a command prompt. So this is created. This will be open. So this will be at the background. This will be running. And what you will see a notebook page, Jupyter notebook. This is called Jupyter notebook page. Okay, so you see the home screen of the Jupyter notebook. So here you see on the right corner, upload. You can upload the files from the location where you have stored your files, and you see a new option. If you click on the new option, Python 2 and SageMath 8.9, because my version is 8.9, so this version actually using Python 2. But if you install the current version, that is SageMath 9 or 9.1, that will use Python 3. So let me click on that SageMath 8.9. You see a Jupyter notebook is created. Don't worry. So you see this page is created like this, and this is untitled. Okay, so this is your Jupyter notebook, and these are the shells. So you see, if you click on the untitled, you can rename that. Suppose I'm giving introduction of SageMath. Okay, this is your introduction of SageMath. You can rename this. So let's rename. Okay, actually file already exists, so let me give some introduction to SageMath 1. Okay, so it's taken, and you see there are file option. You can save your codes, edit, and here is the option plus. So you can put, if you click on this, it will increase the cell below, and there is option also this direction. These are move selected cells up, move selected cells down. So these are the options. You can use these options also. And this is a scissor. You can cut selected cell with whichever is not needed. Suppose this is selected, so if you click on this, it will cancel. Okay, and you can run the program. I will show you the run the program, how to run the program. And there is a code. If you go here, code and markdown. So let me click on markdown. What is the markdown? Markdown is you can give the title of your page. This is the introduction of SageMath 1. It's okay. You want to give some subheading. Suppose I want to use, suppose I can put my name. Suppose lecture 1. Lecture 1 by, suppose my name. Okay, and if you click on the run, it will run the program. Or what we can do, we can do shift enter together, shift enter. So you see the code is running, and it will give you the subheading. Okay, no, this is not a code, this is markdown. So let me give shift enter. Yeah, this is suppose. So lecture 1 by this, and you can give another subheading. Suppose I want to use SageMath as an advanced calculator. So advanced calculator. So you can increase the script, or suppose by this, by adding hash. So let me put more hash, or you can decrease. So you see the scripts are here, and this is your subheading, SageMath as an advanced calculator. So what is the calculator? So let me add some cells. Okay, these are the code. Now let's suppose I want to add 2 numbers, 6, 7, 5, 8, 9, 3 plus randomly you select shift enter. So you see two numbers are added, or we can subtract two number. Shift enter. So two numbers are subtracted. We can multiply two number. Okay, this is your multiplication result. Or we can find the power. That is, suppose 759 power is denoted by double asterisk. Here the multiplication is denoted by asterisk or star, and the power is denoted by double asterisk. So suppose I want the power of 759 to the power 12. So let us enter. Yeah, this is the number. This is a big number, huge number. So this is how you can calculate the simple operations. Also we can divide, right? We can divide, suppose 79 divided by 12.0. okay, yeah, this is the division result. And if we want only the quotient, I don't need the decimal places. So in that case, suppose you are writing 86 double slash, okay, 12, you see the quotient only 7, okay. And if we want the remainder, suppose, so we can calculate that. Suppose 79 percent is the modulo. If you're talking about the modulo, so that is, and also you can put some comments on that. That comments are not considered as in the code, so you can put some comments here for your understanding, okay. Suppose I am writing returns quotient, okay. So let's enter. Yeah, you see, if you divide 79 by 12, 7 is the remainder, okay. This is how you can put some comments beside your code, so that those comments are by hash symbol, so those are not calculated as a code. So this is how you can run the program, okay. More, suppose simultaneously we can do a lot of operations on that. Suppose 70 into 867 plus 3 4 5 6 and minus 876 into 34. So let us, so many operations together, so it will give you the result simultaneously. So it's a beautiful calculations you can do, lot of calculations you can find here. Also, suppose I want to calculate sine 81, okay, dot n, and suppose digits, you can write the digits here, digits equal to 20. N is the number of digits you want. So let us calculate that. Shift enter. So it's star means it's running the program, it will take some time to calculate. Yeah, this is the value. You see there are 10 digits, you see 10 digits. And suppose you want to calculate suppose cos of minus 2.3, okay, calculate. Yeah, this will give you the values. So here you also can restrict your digits by writing dot n, digits equal to how many digits you want after the decimal, okay. Now also you can calculate tan 1 by 2, tan half, okay. Shift enter. So you see the calculations. Also you can calculate the inverse. So the inverse function calculate a sine minus 0.2. Okay, that is the sine inverse minus 0.2 that you can calculate here. Also you can calculate exponential of 1.0, and you can put some comments on that. Return Euler number, right? Okay, so let us calculate that. Yeah, you see exponential values are lies between 2 and 3 that you can find here. Okay, 2.71 and so on. Okay, also you can calculate pi, value of pi. This is the value of e exponential. Also you can find pi. So pi, suppose I want, how many digits you want? Let us suppose that I want 100 digits. Okay, let's pi dot n digits equal to 100. Shift enter. You see there are 100 digits of pi. Okay, next, so many things you can. Next, suppose you have, I think you would have seen golden ratio, that is the phi. So let us calculate. Golden ratio is an inbuilt function in, there are some inbuilt function in SageMath. So pi, exponential, sine, these are all inbuilt. Okay, so you can calculate golden ratio dot n. Okay, so yeah, 1.618, this is the golden ratio. Okay, you can check that from the internet. So this is, and you know that golden ratio is the consecutive ratio of two Fibonacci numbers. So let us check that. You know that golden ratio is nothing but the ratios of two Fibonacci numbers. If you calculate the ratios of two consecutive Fibonacci numbers, that will give you the golden ratio. So let us calculate Fibonacci. Okay, Fibonacci, suppose I want 31. Okay, divided by Fibonacci, suppose 30. Two consecutive, 31st term and 38th term dot n. Okay, now write shift enter. Yeah, you see it's close to this value. Yeah, it's very close to this value. So you can check that for any Fibonacci, two consecutive Fibonacci numbers. Okay, let me show you more. You can have Euler gamma function. Okay, so shift it. You can have some Euler gamma function. Okay, the value of Euler gamma, and also you can find factorial. Suppose f equal to factorial of, suppose tell me any number you want to calculate, any number, suppose 675. Okay, let us calculate the factorial of 675, and you want to see the result. So let us write printf. Just write, very easy to write the code on this Python, actually Jupyter. No need of, actually you don't need any basic Python language understanding. No need, there is no use of that. Even I have learned SageMath first, after that I have learned Python. So there is no use of, but the background is obviously SageMath background, something is running, the code is running with the Python, and Python is required in the background. But SageMath has its own built functions and own language. It's a very enriched language, so you can explore yourself. Okay, so let us calculate the factorial. You see a huge number. Okay, you see, so SageMath has a possibility to show you such a big number factorial, and that is why this is very useful for those people are doing research on number theory. Okay, this is the factorial. And if you want to calculate how many digits are there, how many digits are in this factorial, so that option is there. So if you want to calculate f dot n digits, f dot n digits, this is the writing, that is you can write by writing the comment so that you can remember what you are doing. So number of digits, number of digits in 675, in 675 factorial. Okay, so let us calculate. You see there are 1619 digits in this factorial. Okay, this is how you can explore your SageMath with the advanced calculation. This is all about talked about. So you can do the things by raising power, any type of calculation what you are doing in calculator, you can do that. And you also you can find out golden ratio, you can explore yourself on golden ratio, Fibonacci, Euler, factorial and all that. Write a beautiful program on that. Okay, next I will talk about, let me write the markdown. So I will talk about defining variables. Okay, shift enter. So I am now I am going to define a variables. So in SageMath you can beautifully define the variables. Okay, let us define a equal to, a is some variable, suppose any number 6578, b equal to suppose 87934. Okay, shift enter. So you are defining two variables a and b, initialize. So a value of a is 6578 and value of b is 87834. So you want to print those values, print of a comma b. Yeah, okay, this is like a order pair. Okay, tuple, this will show you like a tuple. Okay, and suppose also you can define the variables like that. First number, you can define first number, you can define, you can give your name, no problem. Okay, suppose any number. Second number, okay, you can give any name to the numbers. Okay, and suppose you want to multiply the first number into the second number. So let me show you. Okay, let me copy this one. Sorry, I don't read to write. Okay, into, so let me write second number. So I want to multiply the first number with the second number. So firstly you define the variables first number, second number, and then you multiply these two numbers and want to see the product. You see the product is given here. So in that way you can calculate with defining the variables. Okay, now suppose a and b is given to you. Suppose let us call b dot. So I'm just now I will give you some more concept on that. If dot tab, if you put b dot tab, so you see there are a lot of options here. You see lot of options. So suppose I want to see b is a prime or not, you want to check. So let us write b is prime and put the parenthesis. Yeah, false, b is not a prime number. Okay, so you want to again, suppose you want to check, b dot again tab. Okay, suppose you want to check the prime factors. Okay, you want to check the prime factors. Where is your prime factors? Okay, let me go more. Yeah, this is your prime factors. Okay, so you can write B is prime parenthesis and shift enter. So you see the prime factors are 2 3 this. So this is how you can calculate. Again, suppose you can show B dot, again you put tab. There are a lot of things. What is the next prime? So B is not prime. Let me give you what is the next prime number after B. So go down. Yeah, next prime, suppose, yeah, 87853 is the next prime number. Okay, you can check factors of B dot tab. So let us check what are the different factors. Okay, parenthesis, shift enter. So you see these are the factors, and this, okay, already you would have seen that these are the prime factors also. And suppose you, lot of things you can do. Suppose B dot, you want to see the binary, so let us put tab binary, that is the binary conversion. Okay, parenthesis, shift enter. You see the binary conversion of B. You take any number was binary, and if you want to see B dot tab divisors, you want to calculate the divisors. You see divisors are there. Yes, lot of options. You can experiment on that and explore yourselves. So you see the divisors are given by this. Okay, and if you want to see the hexadecimal, so okay, tab, you just go to hexa. Where is H? You just find out. Yeah, this is a hexa. So put on that. Okay, so this is your hexadecimal representation. Okay, so lot of things you can do on Sage by this tab. This tab is very important. You can explore yourself. Okay, now suppose I'm choosing any number randomly. I will select some number. Let us suppose n equal to randomly. Okay, so this is your number, a big number. Okay, now I want to check in, is this a prime or not? So dot tab is prime. You can do by tab option also. Is prime. Some mistake I think. Okay, let me cancel this one. Let me again try n dot tab. Okay, let me initialize this. Okay, let me put dot tab. Now find out is prime. Yeah, parenthesis, check. Yes, false. This is not a prime number, so it is mentioned. So you can check it. Okay, let us calculate. In the previous case you have already defined A and B. Let us calculate what is the GCD of AB. Okay, greatest common divisor of AB. So GCD of A comma B, shift enter. Yeah, 2. Okay, this is a GCD of AB. You can find the LCM of two variables A and B. So that is the advantage of defining the variables. You can calculate the LCM, and suppose you can calculate X GCD AB. What is that? Yeah, what is that? You can write here that you know that G equal to S into A plus T into B, that is there exist unique integers S and T such that you can write the GCD, you can express the GCD that you want to find out. Okay, these are the values of S and D. So GST you are calculating, so G is the GCD, GCD is 2 already you have calculated, and these are the unique integers, so this is you can express, so any integer can be expressed as a unique representation of its GCD in terms of two unique integers A and B. So this way you can calculate this. So you can write this comment by writing this hash. Also you can say suppose I want to verify that whether it is true or false. Let us d comma x comma y equal to x GCD of A comma B. Okay, okay, now my question is d equal to symbol is given by double equal to. Okay, now let us check whether my statement is wrong, whether my integers, unique integers are wrong or correct. Yeah, true. So this is how you can check your statement. This is true because so this result is true. Okay, now suppose you can list, you can apply a list option. So list, you can apply your list option to list the primes between 50 to 1 to 100. Let us list all the prime numbers from 1 to 100. Let us list that. Okay, you see this is the list. Okay, excluding this. Okay, this is your list, tuple, dictionaries. I will discuss in my next lecture, don't worry about that. So in this way, how many, let us calculate Euler phi functions. Okay, you know Euler phi is an integers, number of integers prime to okay, you know Euler function phi functions. Okay, there are up to 100. So Euler phi functions up to 100, there are 40. Okay, in this way you can explore yourselves. Okay, suppose I want to list the primes. Okay, let me copy this one. Let me copy this one. Again I want to calculate what is the prime number from 1 to 1000. Let me list the prime number from 1 to 1000. Okay, shift enter. You see there is a huge list. You want to calculate the prime numbers, it will give you the list of prime numbers. This is how you can define your variables in SageMath. Okay, next I will define, so next I will define defining functions. So let me apply defining functions. You can define your function here randomly. You can define your function. Suppose fx is equal to cos of x square into exponential of minus x, okay, plus 3 into x square plus 2, a big function. Okay, a complicated function. You can take a complicated function, no problem. So you can write the function in this way, just like you have written. It's a very simple code you have to write in case of functions. For power you have to write x square, exponential of minus x, and multiplication you have to put a star sign. So any type of complicated function. So I am choosing these functions. Shift enter, initialize. So your function, so you want to calculate any value at any point. Suppose at 4.5, what is the value I want to calculate? Parenthesis, I want to calculate the value of the functions at 4.5. Shift enter, you see the value will be calculated here. You can calculate the differentiability of the function. This will give you the differentiation of this function. By default, if you don't give any value, it will give you the first derivative, but you want to calculate the third derivative of the functions. So let us calculate let us write diff inside parenthesis 3. So I want to calculate the third differentiation, order 3. So this is your third differentiation. Okay, this is how you can define the function. You can find the derivative of the function and third order differentiation. Also, suppose you can define the variable like this. A variable t is defined, okay, and suppose a function gt is given by sine of suppose t square or t cube, okay, plus 3 into t minus t cube. Okay, this is how you can define your function. A variable t is defined and gt is suppose anything. You can define theta, you can define y. This way you can define the functions, or you can define two variables, variable inside parenthesis x comma y, okay, enter. And suppose it's a function of several variable, you can define hxy, so sine of x square minus y square, okay, this. So this is how you can define a function of one variable, a function of several variable. Okay, you can find the value at those points, you can differentiate that and all that. Okay, so today's last section I will discuss about suppose solve. You want to solve, or you can suppose you want a help of something. Suppose help you want to know about something list. So you can put here, you want to see. So there is a help option in Sage and it will give you a list of options, so that you see. If you don't know anything about list, it can, there is a inbuilt module list. How will you write, how will you think? So every detail is given here. You can put a help option and it will give you detail here. So this is how you can check your help option here in Sage. So I think today lecture you have learned how to use the tab, how to use different variables, define a variables, define a function, and you can calculate different things, SageMath, prime, etc., Euler and all that. So this is the basic introduction class. I hope today's class is helpful to you. So follow my videos. I will post very soon the next video. Take care all of you. Thank you.